Alright everybody, I'm just going to make a couple of quick announcements before we get started, okay? So, as y'all know, it's like an 80-minute lecture and we have 6 presentations to do. Each presentation will be 12 minutes plus a little bit of Q&A, okay? So if you're going to finish before 12 minutes, it actually like helps us out for, the sake of getting through it. But don't try to like rush through the presentation, okay? Worst case, we can go over into the next class or like next week. Really quick, logistic thing here is we have like a paired up team that's going to be asking questions to this group. You can find that on the Code Walkthrough presentation signups. Okay, it's also like linked on the lecture slides. So this one we have team 4 going first. They're doing the replace text feature, but then team 2, which is Kavi, Subhash, Adarsh, and Chiahan, y'all are going to be asking questions, okay? So maybe like do 1 to 2 questions, try to prepare 3 questions, and then we'll see how many of those 3 we can actually ask, all right? But maybe y'all will just like raise your hand and ask.
Question on what kind of questions are like?
Yeah, so I think you can either ask like that's a great question. Great question. So you probably either want them to answer something. You can have like a clarifying question, something that you were confused about. Ask if they can go to the part of the code base that does this. Maybe you can ask like how does a specific part of the feature work that they didn't necessarily show. You could ask maybe how something relates to the rest of the code base, something like that. I'm not exactly sure what like exhaustive list of questions you could ask, but I think anything that you would want a bit more clarification or explanation on sounds fair.
Does it necessarily have to be at the end of the presentation?
I think let's do that so that we don't sort of disrupt what they've kind of prepared already. So we'll hold the questions till the end. And then last announcement before we just get started is that right now I think course evaluations were released like yesterday. And so, we're going to actually just set aside 15 to 20 minutes in class in week 10, okay? So you can hold off on doing them for this class. We're going to have like a sort of like 30-minute period where y'all do the evaluations and we'll maybe do like a seminar style feedback for a little bit because we want to make this class taught to like way more people and we want to fit it in somewhere into the existing CS curriculum, so I think like a group discussion on that would be really helpful. So yeah, don't do the course evaluations unless you really want to. Till like week 10, we'll have time in class. Are there any questions before we go ahead and get started? Okay, so I'll be like timing on my phone and I'll probably cut teams off at 12 minutes and maybe I'll try to give like a 5-minute warning or a couple minute warning. Okay. All right. Neither of you need that. Okay, that's fine. Take it there.
I'm sorry, I thought there was
Alright everyone, let's quiet down and we'll go ahead and get started. I'll start timing on my phone whenever y'all begin.
So our team is Five Overflow and we're covering the replace feature in idle. I'll give you a quick overview of what it looks like. So let's say you have an editor window open and you invoke it with Command R. Let's search for a word. So it has like a find feature where you can just like, that's an experimental change, I'll cover that later. But basically, like let's say we're finding idle in the editor, you can either search up or down based on like what direction you have chosen. And then there's a replace feature, which is you can just replace whatever is like selected, and then it just replaces it with whatever you've entered. There's also a replace plus find, which will like continuously replace, or it'll find the next, like let's say the next occurrence of idle, and then replace it with meat or whatever I put. So you can see like idle got changed, and then that idle got changed to meet. And then there's a final feature that's called replace all, which will just replace every occurrence of that word in the whole file. So let's say I wanted to undo like all the changes to meet. Like if I just replace, I replaced like all occurrences of I think meet with idle. I don't know. So yeah, so I actually removed all occurrences of meet. So if I try to find it, it's not there anymore. So that's basically the overview. I'm gonna go over the part where like the buttons get made in the search dialog feature. So when you invoke it with Command R, I have this breakpoint set. So this is one of the code navigation techniques we're using. You can see eventually, if I show you this call stack, when you invoke it with the replace event method, it will eventually call this create command buttons, which we have right here. I guess the breakpoint got hit. But basically, so since the replace feature is like inherits from the search dialog base class, it'll create like a command button from the search dialog base class, I guess. But then these other buttons are made within the replace.py file. And then they're bounded to these other helper functions. Like some of these are helper functions because, like let's say find it, it'll call another function called doFind with the parameter false. It's because like in these bindings you can't really pass in functions or arguments. So, but these other some methods they're not helper methods basically. Like replace all. This one just influenced the full logic for the search feature. I'm running up on my time, but that's pretty much where the buttons get made. And I'll pass it over to Fayaz to talk about the options.
Just sorry, can y'all make the font bigger on the VS Code actually? I think you can do like command and then the plus button. Yeah.
Okay.
Perfect.
Cool, and along with the replace feature Isaac introduced, we also have some fancy operations. If we were to do Command R to get out this replace dialog, we would see we have several options such as regular expressions, match case, and whole word. So for regular expressions, for those people who love CSC 105, you can search for it using D+, and let's just replace it with nothing. It'll do a replace, or we can find it, for example, and we'll see it's highlighting 0, as that's a digit in regular expression syntax. We can do the same with match case. How match case works is that it ignores the caps lock feature. So for example, text and text, even though we're separated by one capital letter, these would be treated different. So we tried searching for this. We would see that only this thing is being highlighted. We can do the same thing for whole word, where instead of searching for the same word of text, it won't give us instances of texting or texted or I have texted, something like that. So if you search for it, find it, we'll see it's doing the same thing of finding text. And wraparound is default enabled, but it's definitely cool if you wanted to use it in a bigger context. For example, let's say the very last keyword here, scroll hard, in this file is the keyword run. So if we tried doing a wraparound and disabling it, searching for the word run, we would see there's no more syntaxes. Yet if we did wraparound, it would go back to the upper instance of it, which is pretty cool if you wanted to do some fancy replace features. And if you wanted to talk about words being enabled, we can go to our search file. I'll just go to our slide we have created here. In our search-based file, create options buttons. Let us go to that real quick. So this is where it's being created, where, for example, we have different options of regular expressions. And if we were to try changing into onshore expressions, for example, try rerunning the debugger, opening the file, Command R.
Play. It's a great one.
Okay. Play, yeah, we now have onshore expressions. And so this comes in handy just to know where these options are being created. And to see where they're actually being used, we can go to our search engine file and see that this function called getLog is returning a cooked search pattern because it wouldn't be cooked if it wasn't working properly. And we see here that several options are working. For example, this is what happens with edge case for regular expressions, and so on. And now I'll give it to Miko to talk more about the features as well.
I will be talking about these the 2 buttons, and I did not mean to do that. Let's see. I'll be talking about these 2 buttons down here, the 2 radio buttons. They are created in searchbase.py's create other buttons class. They use the tkinter's radio button class to create these 2 little thingamajiggies. These 2 buttons themselves have a mapping of 0 and 1, and these 2 values are used for the isBag function, which essentially just gets the value associated with either of those 2 buttons. And that method itself is being used inside the search text function inside the search engine class. This is the main function that the feature uses. Inside replace.py, you can see, if I scroll down right here under the doFind method, we can see that the search text function itself is being used, and the replace feature itself is implemented under this function. And if we take a look at where it's being called, we can see that the simplified application of it is under this method. So if we find a particular search query that the user has inputted, then we replace it. And that's all from me. Ignorance.
Cool. So for me, I will be covering the diagram explanation. And so the 2 main, parts that this replace feature is broken up into is it's broken up into the logic and the GUI. And so most of the logic is being done within the replace dialog class, whereas the GUI portion of it is being done in the search dialog base class. And just to show you the diagram we have made for this, we can see that we have all the relevant classes. We have a replace dialog, search dialog base, text tkinter, search engine, and so on and so forth. And so just to go into how the replace dialog feature or class is, it has this open function which opens the actual replace dialog class. So you have, for example, we have the actual box for it, which opens, and then the create entries function creates the actual it creates some of the buttons. I think it creates the close button because that one's shared between all of the different find feature and graph feature classes. You have the create command button, which creates the button to replace close find. You have the find it, do find, which handle the find feature, the find functionality of it. Replace it, do replace, which has the replacing feature of it. The default command is the command for this replace plus find, the logic for it, in which it just does replace and then calls find afterward. You have this replace expand, which handles replacing for regular expressions, replace all, which replaces all the instances with a loop. And then show hit, which highlights the actual word that you find / replace. And then close, which closes the replace dialog box. And then what this replace dialog class does is it inherits from the search dialog base class, which is the common class between the find feature. So we do command F. It's the common class, the parent class of the search dialog feature and also the replace dialog feature. And so it has common functions like create widgets, make button, open, create entries, which handle creating the actual box for the find and replace feature. It has create option buttons, which creates these option buttons. You have the create other buttons, which I don't know why it's called that, but it creates the direction button right over here. And then you have the create command buttons, which create these set of buttons on the side over here. It creates, I think, just a close function, or a close button because that's its shirts and all of that. Otherwise, you have these other helper classes of the search engine, which mainly handles like searching within the file for the instances. You have this, and uses like this text hinter to like help it, and also like to call these like index search, and then tag add tag remove, which handles like the highlighting property of it. And then you have these other classes over here, which mainly handle the GUI aspect of it. It has the top level, and then it has like miscellaneous and grid, which both work together to like position the actual buttons within the dialog box. And then you have the window manager class, which handles like putting the title, like for example, replace dialog over here. Handles putting that, also the icon name, which I don't really know what it applies to, but I guess it gives a name to the profile. And yeah, that's all it is. Any questions?
Yeah, we'll take questions.
Yeah, can you go back to the class diagram? Yeah, that's a lot. How did you? I guess it's a lot to like digest right now. But like, how did you know where to start? Like, you picked a feature, sure, and then, but it's like it's a big code base. Where do you like?
So replace dialog was that's where the logic is handled. So it's just like a simple control shift F to find like for example replace dialog. To search for that, we need to replace dialog.
So wait, so you're telling me you knew replace dialog was the right class to start from?
Yeah.
Yep, and I guess that's how. Oh,
like it's right over there. So you just search like this, and it'll have you to that class. To find like the actual like tkinter stuff that are associated with it, it's just a matter of like going back to like where replace dialog inherits from, and so it inherits from the search dialog base class, and that's just a matter of like looking at the replace class and seeing like what it inherits from search dialog base. And then once you go back to there, it just has like instances of them. So like for example, frame. Let me just try this. So it has like frame over here. It has an instance of frame class. That's where I got this one. And then it's a matter of like finding what else it has where it's close. And then the top level, it's just a matter of I think it's just top level. Yeah. So it helps inherit from top or has an instance of top level over here. And then I just follow like what it inherits and stuff like that. And like what I see that's useful, relevant to replace dialog within those classes. Does that answer your question?
Yeah, I guess so. It makes sense. I guess maybe the little thing is that replace dialog is one word versus the word replace, the two word replace dialog. I mean, maybe I would have also tried like that as well as a combination. But yeah, I guess.
So in that dialog, there are two options to search either upwards or downwards. How are those implemented?
So those are implemented or created.
Go ahead there.
Sure. So those are implemented within the search base class, right? Which one should we use? Or the up and down button, I guess.
Great on box.
Great other. Yeah. So it's implemented over here, and so what it does is I'm not sure I like the nitty-gritty of it, but it has so like these this other variable. It's just not a list that says, all right, for one, we're going to bind it to the Boolean value of like true or 1. And then for down, we're going to bind it to the Boolean value of 0. And then what it does is it has a radio button class which takes in that other, or no, it doesn't. It takes, well, it looks through others, and then it passes in like the 1 and the up, and then the 0 and the down, into radio button. And what radio button does is it just, whenever like you press whenever you press up or down, it'll set like some variable called.
So this one right here, backbar.
Yeah, backbar, which is.
So that gets used in like the search text method that Miko was covering. It checks if it's 1 or 0. If it's 1, it'll go up. If it's 0, it'll go down.
Yeah, so like backbar is a Boolean variable, and when it's set to 0 or false, it will do the down to search. It'll do this function called search backward, I think, or one of them. But yeah, if it's 0, which it'll use this search is back function, and if it is, then it'll search downwards. Otherwise, it'll search upward if it's set to 1. And so that's how that direction up and down works. So, does that answer your question?
Okay, awesome. Let's give one more. Okay, sweet. Yeah, so we'll have the next group set up. And just one thing to remember for presenting, just try to make the fonts pretty large, like for zooming in on VS Code or when you're showing the diagrams, okay? Just keep in mind in the back it's a bit hard to see, so just try to remember that. All right, everyone, let's quiet down now, and y'all can go ahead and get started with the presentation. Oh yeah, whenever you're ready. All right, let's go ahead and get started. And let's make the font maybe like 1 or 2 bigger. I want to do like there we go. Yeah, that's not good. All right, everyone, let's quiet down and focus on this.
So ours is on a module browser. It's definitely not as complicated as the first group. That was a lot. But so what we're going to do here is I cannot click the term, so I guess we're not. Alright, so we're doing module browser, and sorry, go to part. So we're doing module browser. So the first thing that pops up is we have to enter the name of the module that we have on SysPath, and I'm just going to show what that is first. So the way you can see that is you can import. And over here we have paths of modules that's already preloaded on the computer. And as you can see, one of them is going to be idle lib right here. It shows the entire path, but you care about the end right here. So I just wanted to show that before, so you know how to use it. And then when we click module browser right here, we can go inside and instead of slashes, we're going to do dots over here. It's going to be lib, idle lib, and we're just going to open browser.py. We're just choosing browser because we're going to go into that later. And when you click it, it opens these two windows here. And as you see on the left, this looks like really familiar code outline from Project 3. And what you can do with it, it's a little glitchy, but if you click it, it goes to, it's like Project 2 when you go to definition. And each one of these Python images right here is going to be a function, and then you've got the classes right here. It's a little bit glitchy, but you're able to go through anywhere. And you can open any file inside. If you wanted to as well, you can open up the file first. Right here. Whatever file you choose. And then when you click it, then you can just automatically open up Module Browser and it'll show up for you right here, which you can go through and click through. So that's basically what Module Browser does with this. So I'm going to pass it up to Brent, then right here. Everyone here, the muscle.
Okay, so to find like where the code for Module Browser is located in the code base, we just did a global search for we just did Module Browser since that's the name of the feature, and so we just look it up. We saw that I guess luckily for us, the first result is this file called browser.py, and then just like scrolling through it, we saw that a lot of this code, especially this module browser class, like dealt with the module browser feature. And so if you look at, for example, module browser, and then like when we initialize this class, one of the variables is this path variables, and so this is the full path of a file to browse. And so if you go into like, for example, the init class or the init function, this is kind of setting up our like window for the module browser. And so we can see here that we like open up the file that we want to. And then here we create the window in this section. And then we kind of just open up the file, get the window, then we just set the title for the window. And then here is kind of where we set up like the and then in this section is kind of where we set up the module browser like tree structure. And so we start off by creating this root node, which if we just follow it using command click is just like the file name, because self.path is just the file name. And then there's these two functions, update and expand. And so this is kind of what I guess like recursively builds the tree for module browser. And so this is like it updates the node, the triage node, and then you go back to the browser. And then you click expand, it kind of just we have these two updates in the views, and then it's kind of just builds that tree structure that we saw in module browser.
Alright. Now we go to the lower classes. Okay, so now we can talk about module browser tree item and child browser tree item. So what module browser tree item is it takes in a tree item right here. And basically, something interesting I found is that IDLE has its own implementation of tree. So if we right click, you can see here that it has its own like tree node class, and then you can see things like class its children and itself, right? So it's basically like the tree and nodes that you learned in like CSS1 and stuff. So we can go backwards. Let's see. So yeah, there's the init, which is just itself the file line. And get text and get icon name is just the text of the function and the icon to the left of it. So if we go back to see how there's these icons here, the Python logo and then the folder. That's the icons that they're talking about. And then here on double click, this is referring to the file itself. But to make it, the difference is that in child browser tree item, it's talking about these lower parts, like these children right here. And you can see that here you can find the double click method, which is like go to line, which we did in project 2. And this part is get icon name, which is either a folder or a Python icon. We could modify this to be I'm not sure why it's like, but well, essentially it will change it to folder. And yeah, that's about it. So we can move to the diagram.
Lastly, the diagram is pretty simple because it mostly revolves around a browser file. And so the 4 classes, tree node, listed top level, scope, canvas, and PyShell follow list are components to build the widget for module browser. And in module browsers also creates the instance for module browser as the root node. And these two classes, child browser tree item and module browser tree items, are classes that implement the functions from tree item, which are init, get text, get icon name, get service. On double click and is extendable. And yeah, these are all for it.
Thank you.
So I have a question for the update method. So is the update method like updating the tree dynamically? It's like when you have a browser open and you did some changes to the browser.py, is it updating dynamically?
No, you would have to close the module browser and open it up again, and it'll have the updated version.
For the user info where you input the app, is there, so I remember you have to use the dot instead of slash. Is there like a sort of reason why they didn't it that way?
We weren't really sure. We just know that the module browser, when you have that prompt, it uses the sys.path variable, and that variable contains a few like pretty complicated paths on your computer. But if you wanted to open like any other file that isn't in any of those paths, you just open it up with like file open, and then you just do command B, and then it'll bring up the module browser for that file. So I guess for like the dot, I think that's just specific syntax for Python modules, but we're not sure like why exactly.
I have one last question. How do they actually find out which the classes and like functions are? Like, do they do something like a string? Do they check the strings, or do they have some like, I don't know, framework, something that they use for identifying which classes and methods are in the module?
Oh, I think it's over. There's a function here, so it's function, so it determines whether. So it determines if this is a if the file is a function or if it's, I guess it's a high level explanation, but that's what I found that, I guess it's self-explanatory that if it is a function, it would produce a Python image.
Is it possible to go to where this function is set?
Right. Oh, like where a function is, like where it's called. Like this function underscore. I think this is where you're going from. This is so this is Does that answer your question?
Maybe we can click on that second thing in the definition. Oh. I think, okay.
Oh yeah. So basically this is like high level and this determines whether it is.
Okay, cool. Nice job. Okay, so the next group is Grace. Yeah, okay. And then the team that's asking questions is Team Shelby, Echan, Zed, Ryan, and Brevin. Alright everyone, let's quiet down and we'll get started with the next presentation.
Hi everyone, we're group, Secret Student Group, and let me introduce our team members. So we have Chris Paul, and we have Jahan and Don Hui, and I'm Grace, and welcome to our presentation. So today our group will help you to work through like a really small but also interesting feature in the title lib. And you can see our title shows surrounding parentheses. So as a name, it will just help you to highlight the surrounding parentheses when you do the code, so it will be easier for the Python user to debug and also to listen with their code. And our presentation will begin with the UML diagram, so it will help you to have a basic understanding for the structure and the logic for the code corresponding to this feature in the code base. And then we will also have the debug and the experiment part with the live demonstration, which will help you guys to illustrate like what's the practical application of that one. So before we start, I want to show you some samples to help you work out and have a basic understanding of how does this feature work. As you can see, so our feature is under the added menu, and it's down there. The show surrounding parentheses. When you put our cursor, when you put the cursor there, and you do that, the first one is a really straightforward and simple example. So it will just help you to highlight all expression, including the openers, one, and the closing parentheses. And when you have multiple stack of the parentheses, it will just help you to highlight each one by one. 1, 2, 3. And for this one, when you have the closing parentheses in a new line, and you just put your cursor there behind the, it won't include the closing parentheses. This one won't include it either.
Maybe can we increase the font size for idle also? So you can click on the python.exe in the very top left, like on the whole screen, the top left, yeah, and then you can click settings. And then maybe all of y'all that are presenting today and tomorrow can do the same thing. And then the bottom left there where it says size 11, you can just increase that to, yeah, it's just something much larger. And then you can click like apply, okay. Okay, awesome.
Thank you.
Yeah.
So I just want you guys to
take a guess for the last example. If I put my cursor there and I do the highlight, do the show surrounding parentheses, will it include the closing parentheses or not? You guys can have a guess.
Yes.
Yes? Okay. Yeah, the correct answer is yes. So why would it be like that? Our group members will help you to explain that and help you to go through the logic for that code.
Okay. So for me, I just want to illustrate the UML first, like how each file comes connected. So basically, like everyone did first in the VS Code, we just use Command Shift F to find the parent match, and also and then the all files that related will show. So I put all file here, and obviously there's a parent match.py which is contain all key function about this feature. We have an editor file which use parent match as an instance, and therefore make it fine, and we can use this feature in the editor window. We also have a config. We will say the dialog includes the setting for various feature, including the parent match, and we also config dialog, which show how config looks like. And also we have a task configure that will test how parent match works in the config, and we have task parent match to test how the parent match works. So this is all related files. And the second, we just go through the parent match really quick. We have several methods here. It's not that much, but there's a reload, active restore, and deactive restore, flash parent events, parent close event, unfinished parent event. Also, we have a restore event. We have a create tab opener and create tag parents, and we have create tag expression. The really important three method will be flash parent events and parent close event, which will how it works to highlight the parentheses. Now back to Jonathan to he show how we debug for this and to see what is work.
So for my part, I'm going to go through some of the function calls in the parent match class and hyperparser class, and I'll try to answer the question posed in the first part of our presentation and explain why that will happen. So this is a brief overview of the key functions calls, and there are flash parent events, and after we initiate a hyperparser instance, we call gets running brackets on it. And then after a series of operations, we return before index, after index, back here, and then we call finish parent event, and they will call a create tag expression, which is the function that is in charge of highlighting the selected area. So on the right, this is the example text I will use, and by putting the cursor on the second line, the indexes will be 1.0 and 2.3, and 2.3 is basically 2.3 is basically the last closing parenthesis. But if we put a cursor on the first line, the output will be different. I will show that with the debugging.
Yeah, we can just try making that if you can do run and debug.
Can we switch device?
Okay. So he exactly uses backpack for debug.
It might also be if the whole key Python repositories over here. You click explore right there. Oh, okay.
Okay, after we put up this on the first line, and we will try to click the button show surrounding parentheses. And as you can see, we initiate a parent match object, which is under like this class, and it goes to the flash parent event function. So now we are going inside the hyperparser class to initiate an object and call this function. The next step. As you can see, after a series of operations, we have already obtained the value for before index, which is 1.0. And the after index is yet to be, we have yet to determine what the value of after index is. And currently we are inside this loop. Oh, sorry. I will increase the font. Okay, can you see clearly with this size? Okay, so the next step, we can see that after index is 1.n. So why would that be the case? We go back here and we see that after index is initiated as self.stop@index. And we try to use go to definition to find out what that is. And as you can see, it is set as stop@index. We try to find all references of this variable. And for the two parts of the if-else statement, the stop@index is all have the value of this, which basically means adding .n to the current line. So if our cursor is on the first line, in our example, then after we enter the if statement, here, then the after index can only be 1.n. So even if we have a closing parenthesis on the second line, the show surrounding parent function can only get to the end of the first line. We will continue back to this function, and the next step will be finish parent event, and the last step will be we head into create tag expression and use this tag config to actually create the highlighting. Okay, next step, it flashes briefly. So yeah, that is basically my task.
Before we get into the experiment, I just want to go over a little bit more definition. As you can see, this function generates a hyperparser object and then called a surrounding prefix. And in the hyperparser, it initializes this variable, which will be used later on to find the first opener just before the cursor. Right now, in the opener, we have these three characters as a opener. So if I want to guess around for the common characters, it wouldn't work. Let me show you an example. So if it's one of the characters in the opener, it will work. But for this, it shows nothing. That means it didn't work. So what I need to do is just to add the character to the opener and see if this works. didn't work. Why? Because later on, like when it generates a hyperparser object, this M call this function, which will only record those interesting characters. And as you can see, this interesting character contains these common characters, but common is not one of them. So what I need to do is to add the column so that the M can detect the column. Add the column, and then remove that. It works. Yeah, that's all.
Okay, let's do just one question because we went a little bit over time there. What was the group that had the question?
So can you explain how the must close equals like true or false works?
That one, this opener. You mean this, right?
In the last example you showed, the get surrounding brackets function has an argument called must close.
Like this?
Yeah, the must close equals false.
Explain how the opener works. You mean?
Can you explain how the must close works?
I think the last parameter in the function definition.
This? Oh, it's due to, it works with, so, but, must close is false when we call the get surrounding brackets. And then there's one more function in the code that is it's not related to the function that we talked about, but you can see here, you call it and then passing truth, then true.
So in the initial, the must close set to false. Because if you are in the editor, you can just type one column, not one, and then you do this feature, it will also highlight. So it wouldn't be you have a back column so to make the feature work. So we set the must close is set to false at initial.
Cool. Okay, nice. Let's give So actually one sort of interesting thing about this is that, yeah, y'all can still head out and we'll have the next group start. When we were doing the practice skill demonstration, we spent a couple weeks trying to figure out what part of the code base to have y'all do for the practice skill demo. And one of the suggestions was having y'all change the hyperparser thing for get surrounding parentheses to add a bracket basically. Right now it works with parentheses and a square bracket. We were gonna do angular brackets, but then it ended up being a lot more. I think there's you have to do some changes to the regex, what y'all showed in the very last example. And we thought it was maybe a bit too difficult, but that was a really cool presentation because we were struggling to figure it out for a couple weeks. So nice job.
We're starting Moksha without the T. So it's me, Angela, Andy, and Kyle. And today our project is what it says, which is just getting color options from a section of the config file and then displaying the appropriate colors for the idle color. So this is what our end result looks like. So technically what we did is that we created like a custom color for our sidebar based on user's preference. And our diagram is that we have the colorizer file, which calls the method get highlight in the config file to get the colors that we want for the idle. And it stores them in a dictionary called tag definitions. And that has the different settings and color settings for idle. And then that dictionary is sent over to the idle config class in the config file. And that will provide this color settings that will be displayed on the idle UI and for future.
Yeah, so where do we start? So we're trying to find how to change the color and which UI each color corresponds to. So you heard my predictor say the word color a lot, and we could use that as a key to find out where to start. But if you use VS Code's basic search function, you can see that there are 3,000 results that pop up. Kind of a lot, and if you're like desperate, then you can look through all 3,000 words. But we don't have the time, so what we can do is use idlelib to readme, and which basically gives a gist of what each file idlelib has and what it does. So I have readme already shown up, but you can also command P readme idlelib or control P if you have Windows. And using the same key I mentioned earlier, color, you can just simply search up color, and most likely the files that involve colors will show up. And for our case, 2 of them show up: config highlight.def and colorizer.py. We'll go over config highlight.def later. For now, we're going to go through colorizer.py. So, so we pop up to here. So right here mentioned. So looking at this file, you can see there's a lot of text, and it doesn't look like there's a lot of color involved. You can see where they store the colors or how they change the colors. So what we can do again is also search up color here, and there are 100 results, which is still a lot. But going through the first few lines, you can see looking at the documentation already provided, you can see oh, this one sets the color option of the text widget, which kind of sounds like what we're looking for. And if you look a little bit more, at load tag def, also has a similar common documentation where it stores the tag names of the text color. And if you see a common thing between these 2 methods I showed, they use this method called get highlight. So we could go through this tab, highlight it, and you just go to definition, and you'll end up on config.py, and I'll pass out to Andy.
So as a reminder, initially we were trying to change the color of the sidebar based on configuration files. So a file named config.py is pretty promising. This is the correct config.py. No, it is not. So I'm going to switch to the local version of config.py using Command P. And here we are. So I believe we were using the git theme, or no, it was git highlight. So yeah, we were using the get highlight function. The command is there's Command T that goes to a specific function keyword. And from here we notice a few things. From the comment, it says that this returns a dictionary of theme element highlight colors. Okay, so it seems like it returns a dictionary of some color of some sort. I see they use a function called get theme dict. So we'll look at that more later. And then they also seem to have this default CFG type thing, which is what we'll explore first. So I'll command click to go to its definition. I see initially it's defined empty brackets, so I'm going to see where else it's redefined using final references. And then we see that it's first defined over here. This is where the other file that Kyle mentioned, config def, comes into play. Config highlight.def, config highlight.def, yes. We noticed that there was a config dash, which is similar to the file that we found earlier, and they use this CFG type. If you go to its definition, you see that highlight is in one of the list items. So that's looking promising. So what it seems to be doing is it seems to be getting a file path to config and then dash highlight.def. So we'll know that config dash highlight.def is something important we should look at later. For now, let's go back to config though. And then we're going to go back to get go up here. Get highlight. So it seems like we're going to access some file inside this function, and then additionally we will use this function down here, which is get theme dict. And what this does, it seems like the first parameter takes in only 2 values, and then the rest don't work. And then it also takes in some theme name or something. So there's a lot of assumptions we made here, and we would like a way to figure out if these assumptions are kind of true. So let's take a look at the testing file. Go ahead. I'm going to get this slides. Oh, preview first, okay. Let's see. So load tagged as config colors, that's what we just saw. So yeah, we'll check the, let's see, is this, we'll do this one first. So, that is the wrong place. Sorry. To look for test cases, I can do, or generally how this repository works is that you write test underscore the file name, you'll find the test file, and then we can go to Control F, get highlight. We see it here. It seems like the first parameter is idle classic. If we look inside the content file, it's inside the brackets. So we can assume that's the parameter must be the thing inside the brackets. And then the second parameter is normal. Inside the file, see normal over here, which checks out because over here we have dash foreground, dash background. So it's normal dash foreground, normal dash background. So I'll give it to you or I mean for text.
Since you're running short on time, I'll just do the quick demonstration for making an experimental change. So, well, here's a quick diagram of what we're gonna do. So, okay, wait, really quick. We're on idle right now. You can see that the sidebar shell sidebar color, and here is the same color, right? But now that we went through what they did to set up the colors and stuff, we're going to change this change the sidebar color to a different color. So we look at here. So well, we're going to change the sidebar color, so it makes sense to go to sidebar.py. So if you go to sidebar.py, you can see there's 2 different classes. One of them being shell sidebar class. And for shell sidebar class, there's different functions, one of them being update color. And here is the code for update color. And you can see, oh, here it references the get highlight function that they were mentioning earlier. And so it's passing in the current theme and element. So that's the definition for the get highlight. And you can see also there's a theme, that's the element. So it's passing line number as an element. And that's basically, so we mentioned earlier, basically get line number, we get the colors from the config highlight.def. And then so it's basically getting color from here, line number foreground and line number background. And there's a reason it's called line number because it's also the color, background color for the show line number sidebar. When you do show line number in the Python editor, But right now, we only want to change the color of the shell sidebar. If we like hard code the color here and change to a different color, that's going to change the line number color as well, but we don't want that. We only want to change the shell sidebar color. So what we would do here, so here we can like add another sidebar foreground color and sidebar background color. So these two are specifically for the color of the shell sidebar. Here, let's add this. And then we want to add this for each of the theme. So right now we added it for the Idle Classic theme. Now we want to add it for the remaining two themes over here and over here. Then we go back to sidebar.py, and then here the update color function for shell sidebar class. So here, instead of querying for line number, we can query for sidebar. And then we can change this to a better name. So let's change this to sidebar color. And now when they configure the color for the background of the shell sidebar, it's going to be the new color that we configured. So, well, it's going to be an arrow now, so let's run it and see what arrow is. So it tells us that in config.py, it cannot find this key. So let's go to config.py, and then it says like, this is the line number that is given an arrow right now, right? So it's saying that ThemeDict doesn't have the key of sidebar foreground. So, and then if we trace back, ThemeDict came from the call of get ThemeDict. And then we go down here, get ThemeDict, it returns the theme dictionary. Here, over here, it returns the theme dictionary. And so the issue is, this theme dictionary here does not have the two new fields that we just created. So let's just add really quick sidebar, foreground, and background. This is just the default. But yeah, if now we run it again, you can see the sidebar color got changed. So basically, yeah, in idlelib, the color stuff, the color settings is like really a lot of them find like the color highlight.dev and like the other files that we mentioned previously. But yeah, that's it.
Okay, let's have the next group at least start going up there, and we'll just do maybe one or two questions depending on how big. But the next group will be like Howard, Arian. So who has any questions for the group that just goes?
So for, I mean, I'm sure you explained that well, but I'm still kind of confused on how get ThemeDict and get highlights are related to each other, especially when like the.
Sorry, can you speak a little louder?
Okay, let's quiet down just for this question.
I'm still confused on how like the get highlight and get theme dictionary functions are related to each other, especially in terms of like the CFG parser and how it like updates the theme variable in the get theme dictionary function, because it seems like it returns that variable in the get highlight function. And I'm just confused on like how that connects to like the config-highlight like file. Does that make sense?
So earlier we showed the in the test case they referenced right? And then we referenced back inside the git highlights that there was a -foreground-background tag that was being attached to its like to the value it gets from the config file, or sorry, not the config file, value that's passed in. So it'd be like normal -foreground and normal -background. We saw that there was a matching part inside the config file, so we can assume, or assumption that we can make, which is what we confirmed with our experimental code change, is that that line is getting color values from the config file. So,
okay. Yeah. So that's not in like the get ThemeDict function though. That's not it.
So the get ThemeDict gets like the whole options of that one thing.
Right.
Like there's a bunch of like normal, cursor, Zara. There's like a bunch of like the color definitions for each of those stuff for that particular thing, and then the get highlight is like getting the color of one particular of those things.
Oh, it's like more general.
Yeah.
Versus like,
It's like current from a dictionary.
Yeah.
Get has current from a dictionary. Get think like just getting a whole dictionary.
Okay, cool. Nice job.
And then we do only have 10 minutes, so let's go ahead and just get started. And we might run a couple minutes over 4:50. If you do have somewhere you have to be, you can leave right at 4:50, but we'll stick around until the end of it.
So yeah, I'll just get started. Everyone, today we're going to talk about the iLive debugger. I'm Howard, I have Chris, Marian, and Ethan over here. And then yeah, I'll just like jump right into it. So just to give like a really abstract overview of like how the debugger is. First thing you know is like we did this in class like last week. You first go to PyShell, and in PyShell it kind of instantiates the debugger. It also instantiates like a remote debugger, which is like debugger _r file. We're not going to talk about that today. But we are going to talk about the debugger file. So, main classes it has is that it has a debugger class, in which it has this function, the make GUI function, that actually builds out the GUI. And then, if need be, you toggle the certain buttons, it'll create those viewer classes. The main ones being the namespace, and the other one being the stack viewer, which we'll go into a little bit deeper. And something to note is that the stack viewer does inherit from the scroll list class, specifically the scroll list, and then that's how it gets implemented. So yeah, like I'll just quickly jump into code and just like locate where it is inside iLive. So I think you all know this by now. Like do a quick search. In this case, search up debugger, and then you want to see like where it is being instantiated. You can see that it's being instantiated in PyShell as debugger GUI. And a way you can double check is that just like comment this line out. That is gonna kill everything apparently. And then it's like pass. I'll just run the iLive, and then it should, if I go here, debug, click on debugger. Don't know why it's still showing up.
You didn't save the file.
Oh, right. Thank you. No, restart it. Still don't know why, but this is the entry point for the debugger. For the sake of time, I'll just pass it on to Ari.
I want to talk a little bit about the GUI. So basically what the GUI is instantiated is in the debugger file. Here. So there's a couple classes here that it uses. The main one I'm going to focus on is just the debugger one. The IDB one, or the IBD one, is the one that controls a lot of the logic for the class. But yeah, so here we can see one of the classes, when the debugger is instantiated, it has this make GUI. So if we go to the definition, you can see it's just a really big method. I'll run through a little bit. This is, as far as I know, just for saving some of the initialization and stuff like that. Here it binds a little bit. It binds the closes. It binds the escape and the button up top that goes to the self.close class. And that's a little bit lower in the same class. It also kind of instantiates it as a little widget. That's what this does. If we go to the definition, the WM title, the WM class in general is just the widget manager, and that just kind of gives the title. So we can see if we like change it to like debug test or something like that, and save and run the debugger. So if we go to the debugger, here we can see it changed it to a debug tester instead. That just kind of gives it the title. And then you can also see if we go here, it also binds the escape to the close, and press escape, and the debugger will turn off. Here, these are the 5 buttons up top that kind of control like the step forward and go back. And it has a button class also in the NFPy, and that kind of bind. You can use that to at least bind it to respective function. These are also declared a little bit lower.
Yeah, here it just does some like pattern stuff. It puts buttons in each in a frame and then like moves it around just to align it correctly. And then yeah, the blue bar is also kind of a class in it in the NumPy. It's basically like the Boolean variable. And this here we just set the initialization of what we want to see in the debugger. So initially we want to set vstack to be turned on and also the locals. Yeah, the vlocal stack and then the vstack to be turned on just so we can see those initially. We also have the option to like click the buttons, the checklist to do any of the other ones. But so like if we set this to 0 initially and save it, then we can and then once we run the debugger, we can kind of see that that's turned off by default, but we also have the option to like enable it again. Yeah, so I think that's all I have time for. I'm gonna give it to Ed. He's gonna talk a little bit about the namespace.
Yeah, so I'm going to be talking about the stack viewer. So you might be asking yourself, what even is the stack viewer on here? Where'd it go? There you go. So just looking at it right away, stack viewer isn't entirely visible. You have to actually run something. So if I open a test file here. Now if I reopen the debugger, it'll pop up over here with like kind of the stack trace of the file. At first, I wasn't actually sure like where like if this was actually from the stack viewer. So to double check that, what I did was I went over to the stack viewer class in the debugger py file. And just in the load stack, I saw that it was like kind of writing some stuff right here. So I made a little code change and just like added test to see what that did. And then reopening it. Now if I run this function, you can see it has like the test in there. So that's kind of how I couldn't figure out how to make the debugger bigger, so I apologize if you're in the back. But there is like a little test right here it says. And then one thing that I thought at first was kind of funky with this was if you step through, it only shows you one piece of the stack at a time. If I open up local and globals, you can see it has like the whole stack trace down here. So I thought that was kind of weird. But when I was looking at the stack viewer class, I saw that it inherited from scrolled list. And just from that name, I was like, sounds like you should be able to scroll through it. And then opening up, if I do use the go-to definition, you can see in the initializer for the scrolled list class, which the debugger, the stack viewer calls, it has some key bindings for key up and key down. So I was kind of like, all right, sounds like I can scroll through it like that. So then went back over and checked, and yeah, just pressing like the up and down arrows lets you go through it. And then back over to the debugger, just from like how it works, it starts by loading the stack, and that's where I made those experimental changes. And then on the when you actually like move to select a stack trace, it calls the show frame. And at first I wasn't sure like what the GUI variable was. I assumed it was the debugger, but to actually confirm where that was coming from, I went to references for the stack viewer class and saw that it created the stack viewer in the debugger class, and the GUI was initialized itself. So then in the debugger class, I looked